So today's presentation is by Stephanie Santschi on drawing from the crowd, combining citizen science and computer vision to study historical Japanese print. So this is really something different from what we normally have. I'm very excited about this presentation. So Stephanie is specializing in, well, as you can guess, Japanese print culture and digital art history. She's currently a postdoctoral fellow at the University of Zurich at the chair of East Asian art history. So she teaches courses on East Asian, especially Japanese art history, and she currently leads a citizen science initiative on georeferencing Japanese landscape prints. She is also revising her dissertation research on Hokusai's early painting manuals for publication. So I think this presentation will definitely be in that space. Okay, let me stop my share, and then Stephanie, you can take over.
Thank you very much for this really kind introduction. It's very nice to be part of this crowd today. I'm just going to enter the presentation mode.
Just quickly checking. Stephanie, did you check the sharing sound as well?
Yes.
Okay, wonderful. Thanks.
Yes. So now you should be able to see only my screen. Is that correct?
Yep. No, this all looks good.
Right. So if it's all right, I'm going to start.
Yeah, please do.
Good. So thank you so much for having me. As was introduced, I'm Stephanie Santschi from the University of Zurich, where I work at the chair for East Asian art history, and that is under Professor Eva Machotka, who is the chair of this East Asian art history. And today I want to share a project that sits at the intersection of computer vision, of citizen science, and of art history. Drawing from the crowd, as I call it, is a citizen science platform that combines computational image analysis with contextual art historical interpretation. And what we're addressing is a fundamental question, namely, how did ukiyo-e woodblock print designers navigate between direct observation, secondary sources, and artistic conventions? And maybe just to briefly define what I mean with ukiyo-e, this is really the Japanese prints, mainly produced in the Edo-period, so especially 18th, 19th century. You can see one example embedded in a landscape on the left. And the title, Drawing from the Crowd, carries multiple meanings. On one hand, it refers to the prints themselves. These are designs that might have originally been based on drawings. And on the other hand, it alludes to the crowdsourcing process. So drawing knowledge from the crowd of citizen scientists who contribute their expertise. So what we're drawing on is insights about historical perspective through today's crowd intelligence. And my presentation today will focus on the platform's design and methodological considerations, with some excursions into art historical research along the way. The prototype was funded by the Nippon Foundation, and I'm now implementing it with support from the University of Zurich's graduate campus. But here is what I hope will resonate with this audience today. The questions this project raises: what algorithms can see and can't see, about what counts as correct, about how we scale close reading. These are questions any of us working with visual archives and even beyond will recognize. So I'm curious to hear your thoughts as well about how this might or might not transfer to other contexts. And let me start with a place that allows me to contextualize some of the observations and issues that occur throughout the project. It's the place called Enoshima Island. It's an island southwest of Tokyo, so within medium travel distance. You couldn't probably reach it within a day, but maybe within 2 days of travel at that time. Of course, today it's only 1.5 hours by train. And you can see on the slide an ukiyo-e print. It's overlaid on a 3D map of Japan with a photographic layer embedded on it. And take a moment to look at it. You can see the distinctive shape of the island and of Mount Fuji, as well as the long beach. So the main question I have as an art historian toward this print is, when creating this image, what, if anything at all, did the designer preserve from observation? And what did they adjust? Think about the specific elements: the island shape, the curve of the beach. These seem drawn from observation, don't they? But then look at the adjusted proportions, especially in the foreground. Those serve the composition, not the geography. Let me tell you what drew me to this research. When I started comparing prints of specific places, such as Enoshima, prints spanning several decades, something puzzled me. Some features, such as Mount Fuji, appear to move, especially in these Enoshima depictions. In earlier prints, Fuji sat typically to the left of the island, and by the 1830s, it shifts more often to the right, where it would actually appear today if you stood on the Shichirigahama beach. So what is happening? Were the print designers becoming better observers over time? Were the fashions changing? Or was there something more complex going on? And the stakes are higher than they first appear. These prints weren't just pretty pictures. They shaped how viewers imagined Japan's geography, back then and also today. Millions of tourists still arrive with these images in their minds to Japan, yet these are not photographs. There's a structure to what is real and what is invented in them. And until now, we haven't had systematic ways to decode that. So my hypothesis is that many eyes together can reveal patterns no single researcher would notice. This is why I built a citizen science platform, inviting people with local knowledge, artistic training, and cultural expertise to help analyze these images systematically. And our approach combines three kinds of intelligence. And let me explain what each of these does and doesn't do. The first one is artificial intelligence. We tested computer vision models to filter large image collections. These are vision language models that can match images to text descriptions, such as clip or siglet. We can query things like prints containing boats or images showing mountains, scenes with bridges. We hope this would let us take the big institutional repositories, such as the Rijksmuseum Art Research Center's about 200,000 prints containing a database, and then filter for landscape in them. That would have been generally useful for us, as an organizational process. But we ran into some issues with this, and I will show which issues these are in a moment. But the second kind of intelligence that matters for us is the crowd intelligence. Citizen scientists georeference the prints by aligning them with the 3D terrain model. And this is really the core of the project. Human eyes making interpretive decisions that algorithms cannot make. What the contributors do bring is local familiarity with places, recognition of landmarks, understanding of seasonal markers, and also of artistic conventions. Multiple eyes reveal patterns that no single viewer would notice. And the third kind of intelligence is scholarly intelligence. Art historical interpretation helps me to contextualize the findings. What I, as an art historian, can bring is understanding of artistic conventions, the ability to read cartouches, for example, and an awareness of how visual knowledge circulated, which patterns were at work. So the patterns we discover need to be understood against the centuries of print culture. But why do we need all three? Algorithmic clustering alone does not provide cultural insights. Also, crowdsourced alignment alone lacks cultural interpretation. While you might get positions, you might not get meaning. And human expertise alone, however deep, doesn't scale to thousands of prints. A single scholar could spend a lifetime on a few hundred images. Together, though, these three components become powerful. And let me give a concrete example of why we need human expertise. I call this the Tatsuda River problem. The slide here shows two types of images. On the left, we can see what I call a more or less representative landscape, a print that depicts an actual river with autumn foliage. You can see the curved course of the water through the valley, the way the hills recede. Someone either observed this, or maybe they worked from the careful observation of others who documented these in gazetteers that this print designer was able to use. On the right, you see something that looks superficially similar. You can also see maple leaves, water, and flowing movement. It's a hanging scroll. But this image is a symbolic invocation. Now, imagine you're an educated viewer in the Edo-period Japan. You see these specific maple leaves on flowing water, and what you would immediately think is, of course, that's Tatsuda River. Not because you've been there, but because for you, having a classical education, the image activates a chain of literary associations which reach back as far as the 8th century poetry anthologies. The Tatsuda River was one of the most celebrated autumn scenes in classical Japanese poetry. These maple leaves aren't depicting a place, they're evoking one. And you would have to be trained to recognize it. And of course, if you look at it through computer vision does classify both images identically. It recognizes maple leaves, the water, the autumn scene. It would not have any way to distinguish the topographic from the poetic. The same visual elements, but entirely different epistemological status. And I argue that this is not an edge case. It's structurally characteristic of how Japanese visual culture worked. And it means that any computational approach to these materials has to grapple with a representational system that doesn't separate clearly what is shown from what it meant in the way that Western landscape conventions do more often. So what does this tell us? When we tested computer vision models for filtering landscape automatically, they failed on Japanese prints. I had to go in and tag manually. Why? Because they were predominantly trained on Western conventions, is my assumption. These models literally couldn't recognize what Japanese prints were doing with space. They tried to apply an English language understanding of landscape to Japanese views, seascapes, and scenes. And that failure is actually a really interesting finding. And at the moment, I'm trying to write this up with my collaborator, Himanshu Pandey. It reveals that landscape isn't a visually objective category. Instead, it's culturally constructed. It is dependent on pictorial conventions, which are specific to each tradition, each culture. This isn't a failure we can fix by adding more training data. The problem is structural. The category itself encodes assumptions about what representation is for. But that also makes it powerful for us humanities researchers, right? The implication is clear. Computer vision serves organizational function, but the human expertise supplies interpretive knowledge, and we need both. Now, re-concept structure, how we think about what the project produces. These emerged from the work that I was doing itself. The first concept I'd like to discuss is significant topography. Unlike Western landscape traditions that empathize more often linear perspective and measurable accuracy, ukiyo-e, so Japanese landscape prints, use what I call significant topography. These are landscape features arranged for compositional effect rather than accuracy. Yet they still make the places recognizable. Manipulated scales, compressed distances, physically impossible viewpoints, these occur constantly. But if key features and their relational logic remained intact, viewers could still identify the location. And think about what this means. Western art history often assumed that landscape images either document or fantasize geography. And ukiyo-e, I argue, operate in a third mode. So they make places recognizable without being mathematically accurate. They communicate that this is Enoshima without claiming this is exactly what Enoshima looked like from this precise position. And I think it helps to categorize topographically significant features into two types. Anchor elements maintain consistent spatial relationships with observable geography across multiple prints by different artists or several decades. So the reliable features themselves let viewers identify the locations, no matter of how they spread. The flexible elements vary freely for compositional effect, and artists move them as needed for visual impact. I'll illustrate this a little bit more later on. The second concept I would like to talk about is the historicity of ground truth. What counts as quote unquote correct depends on who is looking, when, and why. Modern terrain has changed through earthquakes, land reclamation, and urbanization, for example. When the prints diverge from the current terrain, this could be artistic manipulation, It could be actual historical change or shifting representational fashions. We cannot assume that any single truth is present against which to measure. Instead, what we have to do is to triangulate. We have to compare prints against terrain, prints against each other, and prints to textual evidence from the period. A third concept I would like to mention is the emergent collective reading. Many viewers together, I argue, see what no single viewer, no single researcher would. When multiple citizen scientists attempt to geolocate prints from the same location and arrive at different positions, that disagreement itself is data. It reveals where the image is flexible and where it is fixed. And in these three conceptual frameworks, I built, of course, on previous scholars' research, especially Marcia Yonemoto's work on spatial vernacular and Tokugawa maps, and Laura Nancy's research on Edo-period travel culture. I have added slides with these references in the end. And what I'm doing is that I'm extending their insights, especially from the textual evidence, which I know many of you are working with, to visual evidence. And now, let me explain what kind of data we're working with. Well, infrastructure matters, and we speak about it a lot in the DH community. The content, of course, is as important. And so for the prints, we draw from multiple sources. One repository is the Ritsumeikan ARC ukiyo-e portal database. There we're still working on integrating it due to this data structure. But we have already integrated prints from the National Diet Library that we access via Japan Search, from the Metropolitan Museum of Art in New York, and from the Taito City Library. One important criterion for selection, you might be familiar with that, is open access or educational use licensing. In total, we started with over 200,000 prints that we selected from. At the moment, we are integrating around 1,700 with more in preparation. The goal is around 10,000 prints. For the terrain models, so the kind of 3D map that you see on the platform, we use digital elevation data from the Japan Geospatial Information Authority with a resolution of every 10 meters. So the data points are kind of 10 meters apart, and they cover all of Japan. And of course, anyone can access the same terrain data we use as it's open access. And for infrastructure, we use the Snapshot platform developed by the Snapshot project at the School of Business and Engineering Vaud, which is a branch of the University of Applied Science in Western Switzerland. So we have an inter-university collaboration here. We also use Wikidata, in particular for place identification, and then also its GeoHack tool Forge extension for coordinates. And as much as we can, we open access, interoperable tools, resources to make the methodology as transferable as possible. One detail that might interest you is that in these prints, what really interests me, right, is the geographic data. So trying even to put the prints on a map, very basically, is quite difficult because geocoordinates aren't standard in heritage collection metadata. If you go to museum websites, that's usually not listed, right? So what I do is that I look up the historical place names, which are part of the print title in Wikidata. And this matters because Edo-period place names were renamed during the 1870s and 1880s modernization. So at that time, the city that was called Edo became Tokyo, of course, you know, and Sagami province became Kanagawa prefecture. So there's really no way of telling that one was the other computationally without creating that link. And Wikidata contains historical place name information, which is why it's so useful. We can make this alignment between the historical and modern coordinates. And of course, it's also one form of citizen science. I should also mention how I generated these lookups. So what I did is that I used AI-assisted scripting, so you might call it vibe coding, to generate Python scripts that then looked up, it created a Sparkle query to look up the coordinates via Wikidata. And then I reviewed and of course corrected the output. I don't have a formal computer science background, but I think I'm literate enough in Python to improve on what the AI generates and then to verify the results. I think the verification step is really crucial here. Maybe only about 2/3 of the lookup succeeded, but this is still way more if you work with 1,700 prints than no lookup, no generated coordination info at all. So it was really a big help for me. And the critical step, as I said, was verification, which I did by displaying the coordinates on a map, which immediately observed obvious errors. One error I foolishly made was to switch latitude and longitude. And of course, if you visualize it on the map and you see the points in an entirely wrong place, that's quickly obvious. So generative AI, I argue, can be genuinely helpful for contained tasks like this, as long as you review the outcome. I would also like to point out that Japan's digital archive landscape transformed profoundly over the last 2 decades. Large collections are now available that simply didn't exist before. But while these platforms provide the access, they're usually not yet designed for visual content analysis. And I think that's the gap I try to fill with this project, drawing from the crowd. And here you can see the full pipeline, and I'll just briefly explain what I did. It makes the methodology more concrete and might be of interest to you in that regard. So, of course, starting the project, I had to explore the field, I had to find out where my data is, if the licenses are available, maybe contact the museums. So really to find and access the images and the metadata. Then in a second step, I had to gather the data that mattered to me. So I had to narrow my data set, I had to download it, I had to store it on my computer, my drive, and I had to go into it and really see what is in there that I need, what is missing, what do I need to add, which then led to the third step, right? The completion of the metadata. So data cleaning. I was working with bilingual information. So a lot of what I did during data cleaning is to match the English and Japanese translations, to work with this, to add key information, to create identifiers for the print designers, and so on. So all this data cleaning work. And of course, and you can see this with the arrows, I relied on this computational support. So it's this collaboration between the human and the algorithm. And then also with the citizen science, which already starts with Wikidata, but then continues into the data enrichment period. Now, the citizen science that I'm talking about, it really happens at this enrichment stage. So I uploaded the pictures, the images to this platform, which I'm going to show you later. And I invite the citizen scientists to visit, to select the print, and then really to help me align it with the landscape. So what they do is, I'm also going to show a video in a moment, they kind of try to think where that print could be, into which viewing direction you would see as a viewer. This is this arrow that you can see here. And then they match kind of let's say the peaks in the print with the peaks in the 3D landscape. They do this on the platform until the platform is able to calculate kind of where the viewer would hypothetically stand. Of course, once this is done and saved, I have to verify the contribution. So this verification step involved. And if it's okay, I can publish it. And this means that the contribution will be published as data on the website, and the print, as you saw on the very first slide, embedded in the landscape, which is also quite interesting for other viewers to see. And then, of course, as an art historian, I contextualize the results. I use the visual information, the data, in answering research questions and continue the research. And the data generated can, of course, also be used in GIS projects. And that's something I'm going to explore at a later stage once we have more contribution. But really what I want to stress with this is that it's really this collaboration between humans and algorithms at each stage, right? The georeferencing happens on Snapshot, of course, and this was originally built to geolocalize Swiss historical photographs against the Swiss landscape model. And they've used it for thousands of alpine images before. And in my project, we've adapted it for Japanese prints, which present slightly different challenges. And the crucial distinction is that photographs, they're indexical. So actual light from the actual terrain passes through the lens, right? So when we geolocalize a photograph, recovering where the photographer physically stood. We can align a photograph from a century ago with the same mountain pass today, and you could, for example, compare the slow line has retreated, or that a specific rock formation is still exactly where it was. But prints are a different thing. They're artistic images. They include interpretation by the artist. They blend observation, memory, convention, and commercial calculation. Imagine a print designer who has visited Enoshima years ago. They might have been seeing other prints as well, and they might recreate the place from their memory using other sources. They might also talk to their publisher, thinking about what kind of design would sell. Think about the Great Wave, for example. So what I want you to grasp is that when we geolocalize a print, we are not reconstructing where the print designer stood. This is important. We are investigating the viewing position the print constructs for its audience. Where does this image invite viewers to imagine themselves? So really what I research is the historical viewing process. Think about what this means for Edo-period audiences. Some depicted locations were familiar, so they might be temples or bridges that they actually visited, especially in their place of origin in the city of Edo. And for those places, the print might evoke recognition. Yes, that's how exactly it looks, or maybe this is an important part, but this doesn't look the same. But then there's other prints which offer visual excursions to places that most viewers would never have the chance to travel to. And these prints, I argue, taught people how to imagine distant places. And so the prints are not just recording a view, they're constructing a view. That being said, on the platform, or with that in mind, the platform offers contributors 3 steps. So you could select the print and see its estimated location. And by clicking on geolocalize, you would enter this localization process, where you navigate the 3D terrain to find the viewing position. And this is often the hardest part because you're kind of playing detective and you have to kind of mentally bridge the historical with the modern map. And you align the print. You can see little dots in the print and in the 3D model of the landscape. You kind of align the same, it's a matching game, right? You align the same points with each other. And it needs at least 6 reference points to calculate the view spot. And what I found works well is peaks, coastline shapes, or hill contours. And less reliable, I found, are buildings which get rebuilt, vegetation which changes seasonally, roads that might really not be in the same place anymore. These are interesting for understanding composition, but they don't necessarily help you to pin down a historical viewpoint. But what I want to emphasize is that when alignment fails, when you generally cannot find a position that works, that is also not a failure on your part. That's a finding. It means this print operates conventionally rather than observationally, or that the place, the geographic place, has in fact changed so much that an alignment is no longer possible. And I would like to just run through the workflow briefly, of course, with the invitation that if you would like to contribute to the platform as a citizen scientist yourself, I'd very much invite your contribution and would be very happy about it.
Today I'm going to show you how to geolocalize a print in Snapshot. You can see me here zooming into Sagami Bay, where I want to geolocalize a print that I know quite well as I have visited this location before. A print that I select is a view of Enoshima Island from Shichirigahama Beach. I browse the prints at the bottom, as you can see. I select one, Turtle Island and Fuji, and I click on geolocalize. Then I mark the position of the viewer, and here it's called the photographer, so probably somewhere on the beach, and they're looking into the direction of the island and of Mount Fuji. I then click geolocalize, and this is what it's generated. It's a 3D model of the topology of the landscape. I first mark Mount Fuji in the background, it's quite prominent. I also zoom into the print to see the other features more detailed. And then I decide to mark the sides of the island. So not the new built parts, the more historical geological structure of the island to the left and to the right. And I also mark this buff that is visible on the shore when you zoom out a little bit, which you can do with the tools on the right. This allows me then to do a first geolocalization. I compute the position, and you can see that already the print has slotted into the 3D landscape model. If I hide the image, I can verify the points, and they already align quite well. This is also shown by these blue circles on the left. But I do decide to remove or relocate number 4, and then I also add some more points. I mark the village that is visible on the print and on the 3D model. And I also decide to mark some peaks in the background. So this gives me a little bit more distance and space and depth to play with, which helps with the accuracy of the geo-alignment. This point is not quite correct. It's shown as orange, so I do reposition it slightly. It could be saved like this though. Keep in mind that these are artistic images, so they're never 100% accurate in how they match. I compute the position again, and what you will see in a moment, yes, here is how it aligns quite well. We have a slightly view from top, but we can see the island is in place. It aligns with how the points are distributed in the landscape. I then can edit some metadata if I want, and I can also add an observation if I notice something particular about this print. And what I noticed here is that, unlike today, the island, Enoshima Island, is not connected to the shore via a bridge. So I think this is an interesting point of departure for further research. I can add this comment, I click next, and bravo, this is the first geolocalization. Today I'm going to show you how.
There we go. So let me show you what this method reveals. So on the slide you can see 3 examples. Hokusai's Enoshima Shumbo from 1797, Hokuju's Enoshima Shichirigahama from around 1804 to 24, and also Hokusai's Fujisawa from the Tokaido series around 1806, and from different institutions. And when you compare these prints, you may notice something puzzling. It's that the island stays put, but Mount Fuji moves, right? So on the left, you can see it left of the island, and then kind of behind the island, slightly to the right in the second, and clearly to the right on the third. And think about that. So Mount Fuji, of course, is a mountain. He doesn't actually move around. But what is moving is the artist's placement of it. And all 3, of course, are recognizable as Enoshima views. Audiences accepted this. But I think it's significant, especially as we have contemporary evidence that audiences notice this kind of positioning. A publisher's advertisement from 1831 by Nishimura Yohachi, who advertised the 36 Views of Mount Fuji series, did explicitly say that these pictures show the shape of Fuji as it differs depending on the place. So the publisher marketed observational specificity as a selling point. And think about what he's saying. He's advertising that Hokusai's prints show how Fuji actually looks different from different locations. And he presents this as something valuable and as something that users, consumers should pay money for. So I think publisher and artist illustrators clearly knew their market. So from this case, and of course also others, I think we can develop a typology. And this is that not all landscape features are treated equally. We do have anchor elements that maintain spatial relationship consistent with observable topography. These stay where they need to be for the view to be recognizable. They're reliable features for the argument. And when we overlay prints onto RAM models and observe that coastline curves match across prints by designers who have never met, what does that mean for us? It could be that they either observed the same places in person, or that they copied from prints that preserve accurate observation, maybe also from each other. Either way, the coastline functions as an anchor. And the flexible elements vary freely for compositional effect. One print might show a beach filling a third of the image, another of the exact same location might barely show it. The beach expands and contracts based on what the composition needs: space for pilgrims, room for a poem, or balance with the other elements. And the surprising finding for me was that Mount Fuji is actually the most flexible element. Despite it being the most famous mountain in Japan, its symbolic presence mattered way more than geographic accuracy. Sometimes it's really in the quote-unquote wrong place. Why? Think about what Fuji's presence actually communicated. It confirmed that the mountain would be visible from that location. That was the essential information. Fuji's symmetrical profile looks remarkably similar from most directions. And Fuji's cultural weight was so enormous that his mere presence sufficed. It didn't need to be in the right place. And what fascinates me is that print designers obviously knew they were manipulating the geography. And this was systematic practice. They were working with a sophisticated visual grammar that audiences understood. And looking closely at which flexible features show similarities across prints, we can detect who copied these features from whom, tracing influence networks that texts alone could not reveal. Now, as this is a citizen science project, one question I get is, how do you ensure quality? And I introduced this validation workflow. So the contributor submits, I review, the feedback goes through comments, and validated prints appear on the map. So every submission gets a human review. But it gets interesting when we have, so as prints are reproducible artworks, right? It can be several copies of the same design. And if we have different people aligning these prints, and we get disagreement, systematic disagreement. And this is actually really interesting because it says the print is ambiguous. It might be a composition of several views into one. And our citizen scientists might only focus on one of these interpretations. There might be general ambiguity. There might be historical landscape change that makes it really difficult to align. And so while high agreement, of course, it's easier to do, the systematic disagreement is where it, for me as a researcher, gets super interesting. Again, this kind of idea of systematic failure revealing actually the more interesting case studies. So disagreement itself being data, multiple. So yeah, that's what I kind of mean with the emergent collective reading, that not just running by my own kind of interpretation of these landscapes, but the patterns generated with a community, with a crowd, that we kind of generate this insight into data patterns that kind of go beyond our own expertise. What I quickly also wanted to share is the semantic dimension of landscapes. And I think this connects directly to why the Tatsuda River problem is not just a training data issue. So the Japanese vocabulary for landscape integrates the viewer into the act of perception in ways the English doesn't. The character ke means view, but it's a view that implies someone viewing. It's relational, not objective. And so shinke means true view, keshiki means scenery, but more literally sense of view. And fuke would be a style view or even kind of wind view. And then again, there's meisho, which just means famous place, which doesn't describe visual features at all. It describes this kind of accumulated cultural significance. You would call something a meisho, which has had poems written about it. Historical events happened at this place. A meisho is famous not because of how it looks, but because of what it means. And this river with maple leaves that I showed initially, this would be an example of a meisho. And then there's Santschi, mountain and water pictures, which doesn't refer to a specific place at all, but more so to a compositional type derived from Chinese painting traditions. So this, I illustrate this as kind of a background to the question why computer vision looking for landscape really struggles, right? I think due to the time, I'm not going to continue into the discussion of chasse and kind of further background on this, but of course, if you're interested in it, I'm very happy to continue the conversation. I'd rather have some discussion at the end as well. Because I would like to talk about the transferability as well. So everything that I described so far, it applies beyond ukiyo-e, I believe. It's not a challenge that we face uniquely to Japanese prints. Studying stylized images where automated analysis encounters its limits. This applies to historical maps that blend observation with convention, illustrated manuscripts, visual documentation, let's say from colonial contexts, and so on. So underrepresented contexts where computer vision models weren't trained. And in each one, images were produced within representational systems that don't map clearly onto the assumptions encoded in our tools. Many of our tools that we use weren't built for the kind of materials that we look at. And when these tools fail, this is my argument, the failure is informative. It tells us a lot about what is culturally encoded in the tools and what is specific about our material. And so I believe that this approach is transferable to this audience, in that I think we have to talk to the communities of people that know about our materials in ways that our algorithms don't, which is why the citizen science is so important to me. It brings human expertise into the computational workflow because automation still reaches its limit, despite all the AI will take our jobs away discussion that we're having, right? Some of these questions really keep on requiring human judgment. And I think that's something I would be very excited to discuss. Now, where are we at now? The platform launched in October 25. We have 1,700 prints available, planning to integrate more. And I think this is quite unique in the field that we have this kind of integrated workflow with citizen science with computer vision. I've mentioned the data sources. And what I would just like to point out, and of course, please feel free to access the project website and the contribution webpage with these QR codes. But I'd like to point out that the most difficult part of this has been actually, or still is, engaging a volunteer crowd, so citizen science crowd. In Switzerland, with this geo-alignment of the Swiss alpine landscapes, we were able to already work with an existing community who has aligned photographs and that were very familiar with the Swiss landscape. And to recreate that citizen science workflow activity discussion with the crowd, this has been quite challenging. And of course, we welcome any contribution. We also welcome any ideas how to expand this volunteer database, or workspace, sorry. I think this is why contributing is interesting. So for the curious learner, you engage with this puzzle, you travel virtually, and you might not need much previous knowledge, but I think there's a lot you can learn from actually going through the process. For example, when I did align some prints, I really learned that where there's streets in Tokyo at the moment, there were previously canals. So even that insight for me was quite rewarding. For DH practitioners, of course, there's the methodology that they get familiar with by playing through the workflow. And educators are also invited to use it to discuss visual analysis and spatial thinking in digital humanities, in digital art histories. It takes about 15 to 20 minutes per print. Of course, there's more complicated cases. And I just want to add that as a Swiss researcher working on Japanese materials, of course, I spent years studying ukiyo-e, and I've visited many of these places, but my knowledge has the limits, right? So the most interesting insights, I think, will come from the crowd, from you, from contributors that bring some of their own knowledge to the platform. And then in return, I also, of course, encourage the platform use for student projects, for research. This is not just built for me, this is built for the wider community. This is how you can get started. You can also track the contributions by username. If there's questions, you can contact me via this email address. So I would really like to share this. I think the slides will get uploaded later, so you know how to contact me, but really with an invitation to participate. And I would like to end with this, not a conclusion, but the questions for you, which might be interesting. How the methodology would apply to some of the visual sources that you work with, historical photographs, maps, or illustrated manuscripts. If there are certain collections in especially Southern Africa, which would benefit from such a kind of platform, even components of this workflow. And also, I think this is always an important question to ask. What are we missing? Am I having a blind spot? Am I not seeing some aspect, especially as I work with underrepresented contexts? This kind of feedback would be very welcome. And with that, I would like to thank you very much for your attention and open the floor for questions.
No, thank you so much, Stephanie. This was extremely interesting. I thought especially the alignment of the pictures, that is so cool. That is so cool. Okay, I see there is a question from Tanya. Tanya, go ahead, while others perhaps are thinking of their questions still, or their answers to the questions that Stephanie had. Tanya?
Sure, do you want me to read it? So when you were, hi, sorry, thank you for a very nice talk. I'm launching right into the discussion, sorry about that.
Sure.
So when you were saying that the concept of landscape is different in the Western view to the Japanese one, right? It got me thinking about the different Western artistic traditions with landscape as well.
Yeah.
So I was wondering if you were to apply a model, like what you did now, to Western landscape, like indiscriminately, would you somehow also get that effect that you got now with, you know, between Japanese and Western art? Because I can think in the different traditions, landscapes are represented very differently.
Yeah.
And one question that I really had was, would one Western type of landscape emerge as a standard from the model's perspective?
Yeah, that's a very good question. It's not a data experiment that we've run so far, because we concentrated on the Japanese case and kind of were initially a bit shocked at how unsuccessful we were. But I think it also showed us how maybe to rephrase our approach to what we even want to find out, right? And I think your question points to that landscape at different times in different geographic regions, in different cultural contexts could be something different. What I'd be interested in, maybe you have an example. So I'm starting with kind of taking a step back. I've been working with this lacquer box, Japanese lacquer box, also with maple leaves and a river on it. And to me, in my cultural understanding, it also depicts a landscape and would never be picked up or categorized that way in, let's say, the British Museum's database. So if there's comparable examples for Western, let's say, Dutch or Swiss or English landscape, that'd be a really interesting experiment to do. Are you working with, let's say, European landscapes?
No, not at all, actually, no. But I'm just an art lover, so I think that's where the question came from. No, I mainly work on languages.
Very interesting. Thank you, though. It really got me thinking. Yep.
Yeah, thanks for your answer.
Cool, thanks. Golnaz, do you also have a question? Do you want to open your mic, or do you want me to? Oh, I see you have your mic open. Please go ahead.
Yeah, sure. Yeah, thank you also from my side for your for your intriguing project. So I was all the time thinking about the potentials, but I'm going to only ask one question, and that is, you mentioned that you're going to use your own observations as an art historian, and then citizen science and AI, and then combine all of the results into, use the results for answering qualitative research questions. So I would be interested in knowing what kinds of questions do you think you will be answering using the outputs of the geolocations resulting from the project that you're doing right now?
Yeah. Thank you very much. Also, very good question. Also, nice to meet you this way. We talked previously. What really interests me is the artistic workflow. And there, I think that geo-alignment can only provide partial evidence to answering this question. But basically, with the Enoshima case and with Hokusai prints, there is this discernible moment where he repositions Mount Fuji. And I want to know why. has he been in place? Can we detect evidence at some point that there's a pattern that has changed after a specific moment in time? And then also to contextualize that within the prints that appeared at the same time, that he might have seen, the illustrated books he might have used as references. So you see, it's kind of a partial quantitative evidence in a qualitative research question. Does that make sense for you?
Yes, totally. But I was also asking myself, because Mount Fuji, in the 3 examples that you showed, we can see that Mount Fuji has been placed differently without having to actually geolocate it on the actual 3D terrain of the map. But then again, connecting those prints with the actual terrain gives us even more information than just seeing that Mount Fuji has been replaced.
Exactly. And it might be because there might be a more distant view. It might be, and there it's interesting to also connect it with the title metadata, right? So at the precise place named in the title of the print, if that refers more closely to actually the calculated viewer position. Or I lost my train of thought there. Yeah, so it's this why question, right, that I'm really trying to answer.
Thank you. Thank you very much.
Sure.
Wonderful, thank you. I actually had, I've got a whole list of questions as well, but we can talk later as well. I was actually wondering, in a similar way, but I had a slightly different question. So you're looking at qualitative research questions, but at the same time, you're essentially collecting data in a quantitative way. So, I mean, you have, what was it, 1,700 prints at the moment. You were talking about several thousands of prints. So you've got these huge amounts of prints, and imagine all these prints, you also have the location, but then you're looking at 3 prints. So I'm not saying that's but what are you going to do with the huge amounts of data that you're going to get? Is there something you can do with that as well?
Yeah. So of course, for this presentation today, I focused on a narrow case study. But what I expect to find is patterns of how the viewing position, so this kind of process of viewing for the viewer changed over a certain historical period. To give you some historical context, in the 1830s in Japan, there was a period of hunger, of economic downturn, and so there was a luxury consumption ban. So it meant that actors' portraits, etc., suddenly were not allowed to be depicted anymore. And from that moment in time on, we see a lot more spatial depictions. And at that time also, I found evidence that travel increased. So I'm kind of understanding this physical engagement with the landscape for the viewers. Like what kind of historical possibility was there for them to actually engage with the prints? What kind of possibility the print designers had to go or not go to certain places, and how that plays together, how this kind of collective landscape imaginary was built. And I believe that by detecting these patterns on a larger scale, that it will help to answer some of that.
Wonderful. No, that sounds really cool. I'm not sure if there are any other questions. I see that we're also kind of running out of time, but Dion, please go ahead.
Yes, I might have a question. So sorry for it. It will take us over time. So something I was wondering, this feels like something that could actually be applicable in things like human geography, urban planning, climatology, especially if people, if you find anchor points, I believe that's the term you used, and then they see how that might have changed and how human relations to the environment might have changed. So I don't know if that's something you've considered or if someone has approached you, but I think that could be a really nice avenue, and also a demonstration of how the so-called softer sciences can contribute to the so-called harder sciences.
Yes, absolutely. I mean, this is certainly a very interesting potential research vector. Coastlines, I think with Japan also you have the seismic activities, so how the places themselves changed. With Enoshima, maybe you saw that I did the comment that the island is not yet connected to the land by a bridge. And so this was also changed over time. At some point, there was this bridge built. And so we get insight in this infrastructure, right? Infrastructural development of Japan at the time as well. And of course, climatology, etc., could also be interesting, with the caveat that we always have to remember these are artistic images. And so the way a sky is depicted might not be unbiased documentation. There might be an artistic intent behind it.
Yes, exactly. And I think it could also be, it could help your work if you actually identify the anchor points more easily with input from geologists or climatologists. If they say, you know what, let's say between two paintings, or two etches, two prints, there was seismic activity, so that might account for certain differences. So I think there's a lot of dialogue between different fields that can occur there.
Definitely. And I think it speaks to that kind of triangulation idea that I try to introduce. So we cannot just take it at face value. We always need to kind of double check what is occurring with a third source, or at least a third source. But that maybe the prints, and seeing the differences, this is where the research questions come, and where we start to see things that we wouldn't have noticed if we didn't have this interpretive layer of the 3D model, right?
Cool, thanks. So I think this is one of the situations where more kind of humanities research kind of links directly with hard sciences. There's normally such a strong boundary between these two. I see, Gonas, you have another question. I think we can do a last question. Please go ahead.
Thank you. Sorry. I will make it short. This is a practical question, because I was thinking when you're marking a 3D view of the terrain, for example, you can mark the tip of Mount Fuji. But then how do you make sure that that tip of Mount Fuji is actually also on the X and Y axis, the tip of Mount Fuji? Because what you're seeing is actually a frontal view. It's a two-dimensional view. And I was interested in knowing that how, or does it make it any difference at all to actually know the latitude and altitude of the point that you're actually marking on in the sky? So it's not on the ground.
Yeah. So basically, the answer to this is that there's this topological elevation model integrated, right? So while we mark the 2D print, we're marking the 3D model of the landscape, so the mathematically constructed model of the Japanese topology. And this alignment then allows this three-dimensional calculation of the viewpoint. And this is why we need the 6 points as well. So we're kind of reconstructing the data for the 2D print by doing this kind of same tagging work in the three-dimensional landscape. And the process, I think, is called monoplotting. And I'm happy to send you more information on that.
Yeah, I would be happy to receive it. Thank you very much.
Okay, wonderful. Thank you. I think we're kind of running out of time now.
Apologies, I talked a little bit too long.
No, that's okay. It was extremely interesting. I hope that this is really food for thought for people. I think we need to talk a little bit more about the citizen science part as well. How do you get people? But these are also questions you had. But I'm sure that there's much more to discuss. But I would really like to thank you for a wonderful presentation. Really something different from what we've had so far. And I thought this was very, very interesting. So thank you so much.
Thank you so much for the opportunity. And I have open doors to anyone wanting to learn more.
Great, thank you.
And so I wish you a good day. Bye-bye.